Okay, a neighborhood recreation program serves a total of 280 children who are either 11 or 12 years old. The sum of the children's ages is 3,238 years. How many 11-year-old children does the recreation program serve? Actually, I love these problems. They're like tiny little puzzles. And you think about what you're dealing with. You're dealing with two specific things. How many 11-year-olds and how many 12-year-olds? That's two variables. So let's say the 11-year-olds are X, and we'll call the 12-year-olds Y. So in this situation, we know that there are 280 children, some of which are 11, some are 12. So I know that all the 11-year-olds plus all the 12-year-olds have to be 280 kids total. Now, that doesn't have anything to do with their ages. The age is the second component, and you can't know how many of each one are just by having 280. You could have 280 11-year-olds and no 12-year-olds. You could have 140 of each one. There's so many combinations. So how we know which one of those combinations is correct is we look at the ages. And I know that an 11-year-old 11 multiplied by how many 11-year-olds there are will give me that total amount of years. So if there are 10 11-year-olds, 11 times 10, that would be 110 years. And then if there are 10 11-year-olds, there would be 270 12-year-olds. So you take the total amount of the ages of the 11-year-olds and add together the total amount of the ages of however many 12-year-olds there are. And I know that when I add those up, they know the total is 3,238 years. So you create one equation that's just the total amount of kids in the program, and then a second equation that has their age as the defining factor. So 11 years times however many kids are 11, and 12 years multiplied by however many kids are 12. And that gives you that 3,238. Now, there's so many different ways that you can solve this. To me, in my opinion, I prefer elimination. You could do substitution. You could even get a graphing calculator and move the equations around a little and graph it. There's even something you can do with matrices. I don't know if you've done that before or not, but there's so many ways. But again, my preference is elimination, so that's probably what I'll go ahead and show you here. Elimination means that we need to get either the x's or the y's to have the same number in them so that we can add or subtract and eliminate a variable. So I'm going to multiply everything in this top row by 11. So let me slide this over a little. So if I do that, 11 times x is 11x, plus 11 times y is 11y, equals 11 times 280. I've got a little calculator over here on the side. That's 3,080. There it is if you're not sure. 3,080. Okay? So what I've got down here on the bottom, I'm going to keep. 11x plus 12y equals 3,238. Now that both of my equations have an 11x, I can subtract one equation from the next, and 11x minus 11x is 0x. So what I've done is I've eliminated a variable. That's why it's creatively called elimination. Now let's look at the rest of it. 11y minus 12y is negative 1y, or just negative y. And then 3080 minus 3238, and I'll type that in just so I don't make any crazy mistakes, is negative 158. Now I can get rid of the negatives, or you could say divide by negative 1 or multiply by negative 1. However you do that, the negatives will go away, leaving you with y is 158. Now remember, that's the 12-year-olds. So I know that there are 158 12-year-olds. If there are 280 students total, then I'm going to take away the 12-year-olds. 280 minus 158 gives me 122 11-year-olds. So there are 122 11-year-olds and 158 12-year-olds. The question says how many 11? That would be 122, which is going to end up being choice B.